Hello, in the last videos we discussed about greedy algorithms and many questions. Let's discuss next one. Here is the question, read it and give it a try. So the question is asking us to return the number of distinct passwords that can be obtained by reversing any one substring of the original password, given the original password that consists of lowercase English characters. So let's say we have to return the total number of different possible strings when we can reverse any substring. For example, if the string is ABC, let's try to reverse the first characters. It will be BSE. Let's try to flip the whole string as it is also a substring. It is CBA. And if it reverse this BC, it will be ACB. And if we try to any reverse a substring with length 1, it will be same as original. So reversing XX will be same as original, that is ABC. So the total number of strings that are possible by reversing any substring at a time is 4. So we have to return 4. And the length is up to 105 and the string can contain only lowercase characters from small a to small z. So what is the basic idea that we can get? So simply we can try to reverse every substring I and j and add all to the set and finally return size of set because we want the distinct count of substrings that are possible. So we can simply try to reverse every substring and we can try to add in a set because we want distinct and finally we can return the set size. So it is simply I is equal to 0 to n and j is equal to I plus 1 to n, because even if we try to reverse I and j with same character, for example I is equal to 0 and j is equal to 0, it will be simply the same character. So we can just try to start from I plus 1 and let's try to reverse it and we can add in a set and finally we can return size of set. So there are two loops and it will be n square. So we can work only with n or n log n. So let's try to remove the inner one because we have to traverse at least once the whole string. So let's try to remove the second one where we are trying to find the number of substrings for every character, for every index. We are at index I and now let's try to find the answer for reversing substring starting at it, because we discussed that we have two loops and we have to remove the inner one. So let's assume that we are at index I and let's try to do the inner loop operation in lesser time complexity. So we're at index I and now let's try to reverse the substring starting at I and ending at I plus 1, I plus 2 and tells on n minus 1. So let's say we found answer for index 0. So we are at index 0 and we found some method to find the number of strings possible by reversing every substring starting at 0. So let's assume that it is count of 0 and similarly we found for 1 and so on we found till n minus 1. So let these values are count 0 till count n minus 1. Is the final answer sum of all these? So we found the number of strings possible by reversing the all substrings starting at every character. So we started with 0 and we tried to reverse 0, 1, 0, 2 and so on till the last one. And we started at 1, we tried to reverse 1, 2, 1, 3 and so on. And we found for all characters, for all integers. Is the final answer sum of all these? So before going to that, let's take an example and let's observe some things. So let's assume that the string is ABCAB and we are initially at index A which is 0. So we are at index A and let's try to find answer for reversing substrings starting at I. So we are at index 0. Let's try to flip the first substring which is AB. So after flipping it will be BACAB and similarly let's try to reverse all. These are the substrings, these are strings possible when we are trying to reverse the string starting from 0, starting from 1, starting from 2 and starting from 3. So is the answer now is 4 plus 3 plus 2 plus 1? It is surely not, because these two are same, because if you try to observe more, this and this are same, this and this are same and this and this are same and all other are different. So if we try to observe I and j for which these are same are 0 to 3 and 1 to 2, it means that when we are trying to reverse 0 3 substring and when we are trying to flip 1 to substring, both are same. And if we are trying to reverse the substring with 1 and 4 and 2 and 3, both are same. So why are these both same and why are these both same? So this is the original string and the first one is 0 to 3 and 1 to. So 0 to 3 is A to A and 1 to 2 is BC. And similarly the next set where they are overlapping is 1 to 4 and 2 to 3. So it is 1 to 4 and 2 to 3. So why these both are same? Because these both characters are equal. Let's say we have a big substring and the first character is A and the last character is also A and there are some middle characters which are not equal to A. Let's assume that this is the case. And now let's try to observe what are overlapping. Let's say we have the same A and initially there is some substring middle in the middle to A and A. If I try to reverse this part, the new string will be A and the reversed part of this, and it will be A. And if we try to reverse this part, it will be A and it will be reverse of the inner part and it will be A again, because these both are same. So even if you try to reverse the whole thing, it will be simply reverse of this, and this A will come here and this A will come here. So simply these both are same. So these two are overlapping. So here is the same case. Here these both are A, and when we are trying to reverse the whole substring ABCA, it is simply ACBA. And when we are trying to flip the inner one, it will be ACBA. And similarly here for BB both are same. So the so these both are equal. This one and this one, these both are equal. So if we try to find the number of whole substrings, which is 4 plus 3 plus 2 plus 1, minus when we are trying to find the overlapping one, because these two are overlapping and these two are overlapping. So there are two duplicates in these 10. So 10 minus 2 is equal to 8. And the initial substring, because we are reversing every character, because we are reversing at least one substring with greater than length than 1. So surely initial will not be counted in any of these. So answer will be 8 plus 1, which is 9. So in this way, if we try to find the total, which is 4 plus 3 plus 2 plus 1, and if we try to find duplicates, then we can simply return answer in of n. So how to find this? Let's say this is the initial string and this is A and these all characters are A. So we discussed that flipping this, reversing whole this is same as reversing this, and reversing this is similar to reversing this, and so on. So if we try to observe one thing, it will be simply for every index I, we want the number of characters at index j at writer index to the I which are not equal to sm. And so what is this? Let's say we are discussing about the same one. So we are at A, right? We observe that the answer is simply AB, AC, and AB, because flipping A till A is same as flipping B to C. So now we will count this one in this. So BC and BCA, and we will not count BCAB. So for every index, let's start trying all, and let's emit those which are having first and last character same. So that when for the next index we can count that substring in the inner. Hope you understand this. So let's discuss this again. So we have this substring, right, and now we are trying to start answer counting from A. So if we are trying to flip AB, the new string will be BA, because this is B and this will be A. These both are surely different because this character is surely not A. So there is at least one character with different character. There is at least one index with different character. So surely these both are different. So similarly, we can try to flip AB. We can try to flip ABC, and let's try to flip ABCA as well, and let's try to flip ABCAB as well. ABCA and ABCAB. We discussed that flipping the substring with first character and last character same is simply reversing the middle substring. So now let's try to emit this one, because we found that we have other arrangement which will result in the same substring when we reverse this one, which is BC. So for starting at A, we will count all the indices which are not equal to A, because only then we can get all the different substrings. And now let's come to next one, B. So now B, we will try to consider C, because these both are not same. So for BC and BCA, we will get the both. So in this way, we can try to remove overlapping ones, and we can count every substring only once, so that we can return correct answer. So we want the number of characters at writer index which are not equal to present character. So for example, we are at A, and we want the count of characters which are not equal to A in the right, because we are assuming this is the first index and we are trying to pair with the last index which is not equal to A. So start from n minus 1 and update frequencies and add answer for present index. So for this, we can simply start traversing from last, and we can try to update the frequencies, and we can try to count the answer. So it is simply for the last character we cannot take any substring, so let's simply add that to the map. So MP of last character will place, and now we are traversing from last but one index, and from now we are adding answer plus this. Why this? Because at an index j, we have next character j plus 1 till n minus 1. So how many? So j to j plus 1, j to j plus 2, and till on j to n minus 1. So how many are these substrings? It will be simply n minus 1 minus j plus 1 minus 1. So it will be simply n minus j minus 1. So simply we are incrementing this answer, and now we are trying to reducing the answer, which will have same substring when we reverse the next part as the next one. So it will be simply answer minus is equal to mp of s of j, which means that the count of the same character at present index. And now simply we are updating the map, so we are increasing frequency. In this way we can try to observe from test cases, and we can observe the observations. So if you have any doubts, comment below. Subscribe for more updates. See you in the next one.